Good afternoon, dear colleagues. My name is Ekaterina Lisova. I'm employee of Light Sea Biological Station of Moscow State University. And today I want to present my work, new data of Nudibranchia rhinophore morphology, case of Onchidoris muricata, Doridina. Why is it important to study rhinophore? The point is that rhinophore are high-specific hemisensory organ of nudibranch mollusk that located at their head region. Rhinophore is a subject of interest for neuroscientists, and their morphology uses taxonomic character. Therefore, the external structure of the rhinophore have been described for many species. But data on the internal structure of the rhinophore are fragmentary. Some studies have serious biological errors. The unique spicle network inside the rhinophore is still not studied. The main goal of our work is to study the external and internal morphology of the rhinophore in Onchidoris muricata, as well as the spicle complex in them, and establish the mechanism of operation of the rhinophore. A total 49 specimens were carried out in the Candilacia Bay of the White Sea. In rhinophore, we study using light, scanning electron microscopy, confocal laser microscopy, biomicro-CT, and three-dimensional reconstruction. Rhinophore of Onchidoris muricata have a lamellar structure with a rounded tape. Rhinophore surrounded by two rhinotubercles and can completely retract it in the well-developed rhinophore pockets. We studied the internal structure of the rhinophore and found that the nerve cords and the lymphatic channel are located in the center. The nerve cords have branches that go into the rhinophore lamella and bifurcate distantly. The lymphatic cavity has small branches and produce into the base of the rhinophore lamella. The cavity does not have its own walls and is limited by the structural elements of the rhinophore. Muscle system of the rhinophore represented by numerous longitudinal muscles and thinner transverse fibers. The rhinophore wall are strengthened by a large number of subepidermal spicules, similar to the body wall. On this slide show the spicules that are found in the rhinophore, and they form the unique spicle network there. So, spicle network is based on a framework of 4 spicules oriented along the rhinophore wall. One spicle row associated with one rhinophore lamella. Different rows of spicules in the rhinophore are displayed relative to each other, like this. First, second, third, and fourth. So, as a result, we get such a spicle network. But that is not all. 2 additional spicules enter each fold of the rhinophore. So now, spicle network is ready. The rhinophore can contract it to well-developed rhinophore pockets. This is due to the muscle of the rhinophore retractor. And the relaxation of the rhinophore is passive due to the injections of the hemolymph. Based on the data obtained on the internal structure of the rhinophore, we can assume a universal structure plan for the entire Doridina. And you can see on the slide the main conclusions. Thank you for your attention.